Problem 10-70, we're taking a look at wires that are on top of a building. The roof of the building is a rectangle. It is 32 by 60, and the antenna itself is 25 feet above the center of the building. What we're going to be doing in this problem is taking a look at a bunch of right triangles, doing a lot of Pythagorean theorem. So, for example, if I looked at this wire right here, it'd be making a right triangle with the antenna and then the line that goes along the roof from the antenna to the corner. So to help out on this problem, we're going to need to take a look at a top view of the building. So it is 32 by 60, and the center of the building, that would be the antenna. So we have two sides that go to these right here. That would be 30 feet long. We have two sides that are going to be 16 feet long that would go to these antennas. And the other four are going to look like this. Now, in order to figure that out, we're going to have to actually do Pythagorean theorem with a right triangle right here. That triangle. Here's my right angle. So to solve that one, I need to do Pythagorean theorem right now. So I would have 30 squared plus 16 squared equals x squared. Solving it for x, I just take the square root of both sides, and then I can type that into my calculator in one step, and I will get 34. So all those there are 34. So now, knowing that the antenna is going to be 25 feet, I'm going to do Pythagorean theorem with each of these. So if I take a look at the green one, it is going to be 30 squared plus 25 squared, and the hypotenuse of that is going to be the distance from the top of the antenna to the edge of the building. There are two of those, so I multiply that number by 2. And do the same thing for the purple ones. So I have 16 squared plus 25 squared. I again have 2 of those. And then for the red ones, I have 34 squared plus 25 squared, and there are 4 of the red ones. Solving Pythagorean theorem for each of these, I get those numbers. And then the green one, since there was 2, and the purple one, since there were 2, I multiply each length by 2. The red one, there was 4, and I get a grand total then of 306.273 feet approximately. Problem B, we're taking a look at the wires that are attached to the corners of the building, and we want to figure out the angle that it forms with the roof. So we're looking at the angle that would be formed right here, that angle. So what I want to do then is take a look at this right triangle. We know that the bottom is 34 along the roof. We know that the antenna is 25 feet up. We want to solve for angle theta. We have the opposite and the adjacent. That is now a tangent problem. So tangent of theta equals the opposite over the adjacent, 25 over 34. To solve for the angle, I need to now use my inverse trigonometry. So I'm going to use tangent inverse, or the inverse tangent of 25 over 34. Make sure that your calculator is in degree mode. If you're not in degree mode, you will get the wrong answer. And the answer is 36.327 degrees. And the last problem, part C, we're taking a look at now, what if the height of the antenna is x feet instead of 25? So what we want to do then is look at what we did before. And before we figured out this, when the height was 25, but now we're going to come up with this in terms of x. So instead of using 25 in each step, we're going to substitute in x. And we're going to come up with that. We cannot solve that because we do not have an x value, but for any x value now we could substitute that in and solve for it. And there's problem 10-70.